We just got a good refresher on Mocha and how it works. Let's now take that knowledge and apply it to these Ethereum contracts. We're going to first start off by getting a good idea of how we're going to use Mocha at all to test Ethereum. We're going to repeatedly follow the same cycle that you see here on the screen. At the very top, Mocha is going to boot up and automatically load up our inbox.test.js file and start to execute the series of tests in there. Inside that file, we're going to go through this same cycle over and over again. The first thing we're going to do is to take our contract bytecode and deploy it to our local test network. Remember, that is called the Ganache local network. This will deploy a new instance of our contract. We will then write some code to manipulate that contract in some fashion. So maybe we will change the message that is stored inside of it. After that, we'll then make an assertion about a value that is tied to the contract. So for example, if during the manipulate process right here, we decide to update the message that is stored in the inbox, then immediately after, we would want to write an assertion that makes sure that our updated message is now persisted inside the contract. After that is executed, we then go back up to the top, deploy a fresh new contract, and then manipulate the contract in some other fashion, and then again, make an assertion about that. So it's the same process repeated over and over again. Now, taking this flow into mind and using our refreshed or newly acquired Mocha logic, let's take some common constructs that exist in Mocha and apply it to this flow right here. So we're saying that at the start of every test, we want to deploy a new contract. Well, it sounds to me like that is some common startup logic that is going to be common across every test we write. That's the entire purpose of the before each helper function. We use before each with Mocha to do some common initialization or configuration logic. So I think inside of a before each, we'll want to attempt to deploy our new contract. Then the process of manipulating the contract is going to be slightly different for every test that we write. For example, maybe one time we want to write a test that updates a message to a new value, and then in another test, maybe we don't want to update the message at all. So in every case, we probably want to manipulate the contract slightly differently. And that means that the actual manipulation should be placed into an it block that is custom for each testing scenario. And then finally, we're going to make an assertion about the contract. And as we've said several times, assertions are always placed inside of our it blocks. And so, yep, this is definitely going to go into an it as well. I'm sure that at this point, you're really tired of me lecturing and you just want to write these tests, but there's just one last little thing that I want to mention before we write code. So I swear this is the last thing. If you recall back to the contract that we had discussed deploying previously when we were making use of Remix, we had said that a contract is created through a transaction. Remember, we looked at this diagram right here. So we take an external account, and an external account is one that you or I create. An external account will submit a transaction with some compiled bytecode in the data field, and then the to field is going to be left blank. Now, how is that relevant to what we're doing right now? Well, remember, the entire idea here is that when we attempt to create a contract or deploy a contract to our local test network that is running through Ganache, we're going to have to make sure that we have some account that we can use to actually deploy it, like an account that you or I create. And so for that, luckily, you and I don't have to do anything extra. The Ganache module that we already installed and have configured inside of our project right here automatically creates a set of accounts for us to use as soon as that test network boots up. The good thing about these accounts is that they are created in an unlocked state. An unlocked account means that we don't need to do any special thing with any private keys or public keys to make access to, or to get access to. So we can just directly make use of the accounts that exist inside of this local Ganache network. Okay, I swear that's the last thing I wanted to mention, so let's pause right here. We're going to come back in the next video and we're going to write out our entire first test. So just a moment.